All right, enough talk, right? Let's get down to some examples. So in example one, we've got a fair six-sided die, and we're going to roll it and observe the number that falls uppermost. That's our experiment. And so the first question just asks, what's the sample space? Well, the sample space is just the set of all possible outcomes, right? Oops, so the sample space, let's write S, is equal to, yeah, all the possible outcomes. So what can we possibly get when we roll a die? We're either going to roll a 1, or we're going to roll a 2, or a 3, or a 4, or a 5, or a 6. Okay, so if we're just rolling one die, that's it. That's all the possible outcomes. The next question is just to find a probability distribution for the experiment. All right, so we're just going to list the simple events. All right, those are all of the one outcome events. So the first simple event is 1. Now, I could put curly brackets around it if I want to. Then it really is a simple event, because an event is a set. It's a subset, right? So, technically, I could draw curly brackets around all of these simple events. A lot of times, though, it's just a lot of more. It's not necessary to put all those curly brackets around in this case, but I'll go ahead and put it in for completeness. So those are all the simple events. And what are the probabilities? Well, when you roll a die, each outcome is equally likely, and there are 6 possible outcomes. So the probabilities are just going to be 1 out of 6 in each case, 1 out of 6. So that's a probability distribution, right? It's just a table of all of the probabilities of all the simple events. What is the probability that a 3 is rolled? Okay, so the probability of a 3. Sometimes I write it this way. Now I could write it as a simple event. I'm just going to say, what's the probability of 3? I could do this and make it an event, which is a set. But the probability of rolling a 3, I could just read it right off the table. It's just 1/6. What is the probability that a 1 or a 5 is rolled? Okay. Well, now this is where we get to apply that property of probability, where we can sum the probabilities of the simple events, right? So I can take this probability of getting a 1 and add the probability of getting a 5. Okay. Oftentimes I don't put the curly brackets around it, but I will in this case, just because it's technically that's what you should do. But so the probability of getting a 1 plus the probability of getting a 5. Okay, we have a 1/6 chance of rolling a 1, a 1/6 chance of rolling a 5, and so we end up with a 2/6 chance of rolling a 1 or a 5, right? So it's basically 2 outcomes out of 6, right? Those and that we can reduce to 1/3. The next question asks, what is the probability that the roll shows an even number? All right, so I'm just going to write that as the probability of even. Now I could write out the event. I could write if I wanted to write the event out, it would be even, right? So it'd be the event of 2 or 4 or 6. Okay, that's the event we're looking for. And then if I define my event that way, then I could actually just write this as the probability of event E. Right, E for even. Well, I'm just going to take the probability that you get a 2 plus the probability that you get a 4 plus the probability that you get a 6. Right? And if I add those all up, it's just 1/6 plus 1/6 plus 1/6, which is 3/6. 3 out of 6, which makes sense because these are 3 possible outcomes out of 6. And that reduces down to 1/2. Okay? So that gives you the basic idea of how probabilities work, and I'll meet you in the next video.